Hello everyone, this is Aditya and today we will evaluate this integral, and surprisingly this integral took me around 1 hour to solve. So let's see what's so special in this integral. But for that, please do like, share, subscribe and please support this video. Now let's start. So this is the integral where n is some natural number. Okay, so we have to evaluate this integral. So let's see how we can evaluate this. Okay. Now at first sight this seems really complex integral because we see an algebraic function, we see a square root function, we see a natural log function. So it becomes very difficult how to start in this case. So surprisingly you see a limit of 0 to a, and over here another a square minus x square. So in most of such cases you use a substitution. X is equal to a sine theta. Okay, so dx is a cos theta d theta. Okay, so when x is equal to 0, then theta is also equal to 0, correct? Okay, and when x is equal to a, then theta is equal to pi by 2, because sine theta equal to 1 means theta is equal to pi by 2. Okay, so we have the expression a sine theta raised to the power of n natural log of a sine theta divided by the quantity a square minus a square into sine square theta times the quantity a cos theta d theta, correct? Okay, so let's simplify it. So clearly a raised to power n can be brought outside. So you have this integral now 0 to pi by 2 of the quantity sine raised to power n times this natural log, and notice that you can write natural log of a sine theta as natural log of a plus natural log of sine theta from the laws of logarithms. Okay, divided by, notice that this expression will be equal to cos square theta, a into cos square theta, I mean a square cos square theta, and when you take the square you will get a cos theta over here, right? I hope so you're understanding what I've done over here. Now notice you should have used a mod sign over here, because when you're taking square root of x square, it is equal to modulus of x. But why I have not taken mod sign over here? Because the limits are from 0 to pi by 2, and in 0 to pi by 2 cos theta is positive. Okay, times the quantity a cos theta d theta, correct? Okay, notice that this and this gets cancelled, so you are left with this integral of this function 0 to pi by 2. Now you can break the integral into two integrals over here, not double integral, two integrals, two separate integrals. Sine raised to the power n theta times natural log of a d theta, correct? This the first one, plus integral from 0 to pi by 2 of the quantity sine raised to the power n times the quantity natural log of sine theta. Okay, and of course a d theta. Okay, now let's evaluate this integral first of all, and it's very simple actually. Let me introduce you to the concept of beta function. Okay, so beta of m comma n, you all must have saw my video on integral calculus. In that I have discussed about gamma function, beta function, all. So beta of m comma n is actually equal to 2 times the integral from 0 to pi by 2 sine raised to the power 2m minus 1 theta cos 2n minus 1 theta d theta. So this is the value of beta of m comma n. Okay, now notice that when you use over here, what you have this expression. Of course natural log of a is a constant, so you can bring it outside. So you have sine raised to the power sine theta raised to the power n d theta. Okay, so you want this expression to be 1, so you want 2n minus 1 as 0, so it is beta of 1 by 2, so this is equal to 2 times the integral 0 to pi by 2. You want sine of n theta d theta, so we want 2m minus 1 equal to n, so m is equal to n plus 1 by 2, correct? Okay, so you have n plus 1 by 2. Notice that you can bring 2 in the denominator, you will get this integral as beta of, so this is actually equal to natural log of a times the quantity beta of n plus 1 by 2 comma 1 by 2. So this is equal to basically this expression. So let me write it over here and let's now evaluate this expression. Okay, so this is the final expression which I have got. Now I have to evaluate this integral, so let's see how we can evaluate this. So integral 0 to pi by 2 sine raised to power n times natural log of sine theta d theta, right? Okay, so now this seems to be really interesting and quite complex, that we have a trigonometric function raised to some natural number n times a logarithmic function inside which we have a sine function. So what method we can apply? Well, of course we know that whatever value it will give us, it will be some function of n, right? Since we are integrating with respect to theta, so the final result will be in terms of n, correct? Okay, now notice one thing. What if I assume just this integral sine raised to the power n theta d theta? For now just assume this integral. Suppose this is equal to some small f of n. Of course this will be also equal to some f of n only, right? Of course this was this integral was this only. Okay, but don't think this integral in terms of beta function for now, because I'll be just manipulating it a bit and probably we'll get answer through that. Okay, so let's differentiate it with respect to n. I am differentiating it with respect to n. Okay, so theta is a constant, so this will be equal to d by dn integral from 0 to pi by 2 sine n theta d theta. So this is equal to integral from 0 to pi by 2 partial derivative of with respect to n of this function sine n theta d theta, correct? So you will get over here integral 0 to pi by 2 sine n theta times natural log of sine theta d theta, correct? Because of course you have to integrate, you have to differentiate this stuff. So sine n raised to power n, when you differentiate it with respect to theta, sorry, with respect to n, you will get this function as it is, sine raised to power n theta. Okay, natural log of sine theta. Okay, so this is the expression which you are getting. Okay, now notice that f dash of n is actually equal to f of n, correct? So we have to evaluate now f dash of n. Okay, so what was f of n? It was equal to beta of n plus 1 by 2 comma 1 by 2. Okay, so now notice one thing. How you can simplify this expression now? Well, you know a relation that beta of m comma n is actually equal to gamma of m times gamma at n divided by gamma of m plus n, correct? Okay, so just use this expression. So you will have gamma of m, of course there should be a divided by 2 also. Sorry, I forgot to write divided by 2 because there we had a 1 by 2 also, right? So over here also it will be 1 by 2 times this value. This will be 1 into 1 by 2. Okay, I'm really sorry for that thing. Times, so what is gamma of m? It is n plus 1 times the quantity gamma at 1 by 2 times gamma of n plus 1 by 2 plus 1 by 2 is n plus 2 by 2 times 1 by 2. Now what is gamma of 1 by 2? If you have watched my integral calculus video, you must be knowing that this is equal to root pi. So actually this expression is root pi by 2 times the quantity gamma at n plus 1 by 2 divided gamma at n plus 2 by 2, right? So we have f of n, where should I write? So we have okay, just remember that f of n is root pi by 2 times the quantity gamma at n plus 1 by 2 divided gamma of n plus 2 by 2. Okay, and we have to find, and this is actually f dash of n. Okay, so now we have to evaluate f dash of n from this expression. So let's erase this and let's evaluate it now. So we had got f dash of n, sorry, f of n as root pi by 2 times the quantity gamma of n plus 1 whole divided by 2 gamma of n plus 2 whole divided by 2, correct? Okay, now from here you have to go to f dash of n. How you will go? Well, in such cases we prefer to take natural log both sides. Okay, so natural log of f of n is natural log of root pi by 2 plus natural log of gamma at n plus 1 by 2 plus natural log of gamma at n plus 2 by 2, correct? Now just differentiate this expression, what you will get. So let's differentiate the expression which we had got. So we had got natural log of f of n is equal to natural log of root pi by 2 plus natural log of gamma at n plus 1 divided by 2 minus natural log at gamma of n plus 2 by 2, correct? Okay, so when you differentiate this with respect to n, and if before I have written it as plus, please keep in mind that this is negative. Here we will have a subtraction sign because it was in division, right? So natural log a by b is equal to ln a ln b. So when you differentiate it, you will get f dash of n, this quantity, this is a constant, right? So this will be 0. Derivative of now this is interesting, natural log of gamma of n derivative is actually psi of n, which is equal to gamma dash of n divided gamma of n. Okay, so this is psi at n plus 1 by 2, but by the chain rule you will get 1 by 2 extra over here, right? Minus similarly over here psi at n plus 2 by 2, but from the chain rule you will again have a 1 by 2, right? And I know you all must be still thinking that why the derivative of sine raised to power n theta was equal to that expression. Then think sine theta as a constant, suppose a. So you have d by dn a raised to power n. Now it is very clear. This will be a raised to power n times natural log of a. This is same as saying d by dx a raised to the power x is equal to a raised to power x times natural log of a. Okay, so this is the value of this thing. Now let's rearrange it. Let me erase this. So you get f dash of n. What was f of n? It was root pi by 2 times gamma of n plus 1 by 2 divided by gamma at n plus 2 by 2 times the quantity 1 by 2 into the quantity psi of n plus 1 by 2 minus psi at n plus 2 by 2. Yeah, that is it. So what is the final result we are getting? Let's write over here. Let me erase this. So this is the final result which you are getting, and now let's simplify it a bit. So you know one thing, that beta of n plus 1 by 2 comma 1 by 2, it was equal to, notice that I have multiplied 1 by 2 in this expression only. Okay, so this was equal to root pi by 2 times this function. So you can write it as natural log of a times root pi by 2 gamma at n plus 1 by 2 by gamma at by 2 plus root pi 1 by 2 into root pi now this expression right. Okay, so yeah, that's the final answer. You can take this expression common, right? You can take this expression common. So what you will get? So the final result is integral from 0 to a x raised to the power n natural log of x divided by square root of a square minus x square dx is equal to the quantity a raised to the power n times the quantity is square root of pi by 2 gamma at n plus 1 by 2 divided by gamma at n plus 1 divided by 2 times natural log of a plus 1 by 2 times the digamma function at n plus 1 by 2 minus digamma at n plus 2 by 2, and that's the answer. And if you don't know about digamma function, I've already made a one shot on digamma function. You can check it out. I'll give the link in description. So this is the final answer. So I hope you enjoyed this video, and if you learned something new from this video, then please do like, share, subscribe, and please support this video. And please share these videos to your friends and family members, because I'm making so productive content for you all, and I feel that on YouTube no one is given such kind of content. So please do share this video and please support my channel, because it will very much helpful for you also, and it will help me also to grow, right? So till then, bye bye, take care, and all the best.